Okay, we are on the back side of the review sheet number 2 for the quadratic equations test. Let's take a look at our directions. For the following questions, show all your work, round your final answers to one decimal place, and write your final answer in complete sentences in the box provided. Now, I'll go over a couple of these step-by-step class, and then for most of them I'll just go through tips for you, because most of these questions are going to be leaving it up to you which solution you're going to, why am I thinking of the word here? Which strategy you're going to use for solving the x-intercepts. Are you going to use factoring? Are you going to use complete the square? Or are you going to use quadratic formula? And I have taught you that in most cases, if it's left up to you, you typically want to use the quadratic formula because no GCF necessary. The A value can be whatever it is. A lot less work to do to actually get the final solution. So I will follow that strategy, although if you want to try factoring or try completing the square, that's up to you. But sometimes an equation is not factorable, and sometimes completing the square gets you some really weird decimals that kind of get more difficult to work with. So there's the intro to this. Let's take a look at the first one. A soccer ball is kicked, and the height is modeled with the equation y equals negative x squared plus 18x, where y is the height in feet, and x is the horizontal distance traveled in feet. So now we're not looking at time, we're looking at how high the soccer ball goes and how far away it goes. Oh, I got a typo here, because one, the soccer ball does not change to a firework, and number two, it's not going to explode. So I think I'll probably fix that on your copy, but since my copy has a weird thing here, since it used to be a firework, let's just say, how far away? Let's get rid of all that. How far away will it land? Oh goodness, not from the launch location. I guess we could say from the launch location, because you're launching it by kicking it, so I guess we could say that. So, but let's just finish this. How far away will it land? Get rid of that. The first thing I want you to notice is when we're talking about a ball or a rocket or a shot put or a javelin or a baseball landing, it lands at x-intercepts. So that means we know we are looking for x-intercepts, and we have three strategies for doing that: factor, complete the square, and quadratic formula. Now let's write this equation. Y equals negative x squared plus 18x. And I want you to see, class, when we're solving an equation, we're going to set the y value equal to 0. So negative x squared plus 18x equals 0. And let's notice something very important. No, maybe you've already seen this, no C term. If you don't have a C term, we can quickly factor this equation. All we have to do is find the GCF and factor it out. Let's change colors here. So our GCF here, let's take a look at it. Our coefficient on the x squared is 1. So our GCF is going to be 1. But our A value is negative, so we're going to pull out a negative 1. And if there's no C term, that means we have a common variable. Both of these terms on the left side have an x. So we're going to pull out negative 1x. I could just write negative x, but if you want to write negative 1x, that's totally fine. So we're going to pull out negative 1x. We're left with x. Negative 1x times x is negative x squared, and we're left with negative 18. And now look, even though it doesn't look technically like an intercept form, it is, because there's no squared term anymore. And so now we can just find what value of x changes 1x to 0, and what value of x changes x minus 18 to 0. Well, in this case, x is going to be equal to 0. In this case, x is going to be equal to 18. Be equal to 18. Now think about it. When the ball is kicked, it must start off at 0. But it's not asking us where it starts. It's asking us where it's going to land. It's going to land 18 feet away. So when you write this answer, I'm not going to write it to save some time. When you write this answer, your answer should be something like, the soccer ball will land 18 feet away, as long as your answer has 18 feet in it. Okay, so again on this one, make sure you write your answer as a full, complete sentence. Let's go to question number 34. A tennis ball is hit and the height is modeled with the equation y equals negative x squared plus 8x plus 4, where y is the height in feet and x is the horizontal distance traveled. It sounds a lot like the previous problem, only now we have a c term, so we're not going to get off the hook so easy like we did in the previous one. Okay, boy, I tell you, I don't know what's going on here. I got really stuck on thinking about fireworks. So in this case, how far away will it land? So let's go ahead and get rid of, again, I think I'll have this corrected by the time you guys get the printout, but just on my copy. How far away will it land? That's all we need. Question mark. Okay. Let's think about this. It's asking us where the tennis ball is going to land, and that means we're looking for x-intercepts. So every time you get a question, you have to identify what part of the parabola are we looking for. In this case, we want to know where it hits the x-axis. So an x-intercept. All right, let's write our equation. And again, I'm not going to work the whole thing out for you. Negative x squared plus 8x plus 4. We know that for finding x-intercepts, we're going to change y to 0. So I've got negative x squared. I'm going to move things over to the other side, as I typically do. And now you got to choose, class. Do you want to solve by factoring, complete the square, or quadratic formula? I'm going to go with quadratic formula since I know it's going to work. So I would now just find a is negative 1, b is 8, c is equal to 4. Now I'm going to go ahead and give you the answers. You can work out the solutions on your own. Let's just verify the final answers here. When you find the discriminant, your discriminant is going to be equal to 80. And when you find your solutions are going to be x equals negative 0.5 and 8.5. And if you know, we're looking for a distance traveled in feet. How far away will it land? Well, it's not going to land negative feet away. So the negative number is removed, and we're going to end up with our positive number. Write your answer as a complete sentence, and in the sentence you're going to mention that it's going to land 8.5 feet away. Okay. Let's see if I got this one worded right. 35. You throw a water balloon from a building 30 meters above a swimming pool with an initial vertical velocity of 5 meters per second. If a is negative 4 meters per second squared, how long will it take for the water balloon to hit the pool? Well, I finally got one where the wording is correct. Now on this one, class, you're going to have to remember what these different parts are. We know that the a value is negative 4.9. And we have learned that velocity is going to be our b value. And our starting height is going to be our c value. So you got to build your equation. It's going to be y equals negative 4.9. Let's just use x squared. Then our velocity is 5, so 5x. And our starting height is 30. First step of quadratic formula. Oh, again, how long will it take for the water balloon to hit the pool? We're hitting the pool. That means we are looking for x-intercepts. So let's rewrite our equation and change our y value to 0 since we're looking for x-intercepts, and we want to see when it hits the pool, and that's going to be at the x-axis, or 0. And now we can identify A, B, and C. A is negative 4.9, B is 5, C is 30. You work out the rest of the results on your own. I will tell you that the discriminant, get you some answers here. The discriminant is going to be 613, and your solutions are going to be x equal negative 2.0 and 3.0. And again, the negative number, now we're talking about how long. So now we do have time on the x-axis, so negative numbers are never relevant when it comes to time. So the negative answer can be removed. And in your final answer that you need to write in a complete sentence, you need to mention that it's going to take 3.0 seconds. And I want you to see, class, the difference between these two questions. This one, height is on the y-axis and horizontal distance traveled in feet is on the x-axis. So we're looking at how far away it lands. For number 35, you got to read the question. It's asking you how long will it take for the water balloon to hit the pool, because it says you throw a water balloon 30 meters above a swimming pool with an initial vertical velocity. Notice that we're seeing seconds in our units. So we know that it's actually going to be showing time on the x-axis. So there are your final solutions, and you need to write your answer as a complete sentence. I'll stop the video and we'll start back up again on number 36.